Good morning, students. I am Manikant Mishra, Modern English School, New Area. As we are continuing discussing the characteristics of period. So, yesterday, one of the important characteristics of periods we have discussed that is a atomic size. And as I have mentioned, it is one of the prominent factors which decides the physical as well as chemical properties of an element. Not only it influences many of the properties. So as for example, today we are going to discuss the gradation or the change or the effect of ionization enthalpy or ionization energy across the period. So once again let me define some, though many times I have explained about the ionization enthalpy or ionization energy. The amount of energy required to remove an electron from an isolated gaseous atom. The amount of energy required to remove an electron from an isolated gaseous atom. So from atom, the electron, if you are going to remove the electron from the outermost cell of an atom, the energy is needed. Energy is need to supply. That energy is called ionization enthalpy or ionization energy. The amount of energy required to remove an electron from an isolated gaseous atom, as for example, like sodium. Sodium has one electron in its outermost cell. So in order to achieve the stable electronic configuration like of neon, sodium has to lose this electron, and for this the energy is needed, that is called ionization energy. Now sodium has to lose one electron. If you talk about the magnesium, magnesium is needed to lose two electrons, and the two electron does not loses simultaneously, rather it is lose one by one only. It is loses one by one only. So when magnesium loses one electron, suppose proton and neutron 2 electron. Now electron, suppose like this way. So what happened, as you know that these two forces act simultaneously. These two forces, electron tries to pull the nucleus outwards and electron tries to pull the nucleus nucleus tries to pull the electron inwards and electron tries to pull the nucleus outwards. So when the number of proton and number of electron are equal, then these forces are balanced. But when you are applying ionization energy, then this electron is removed. The energy involved to lose one electron, that is called first ionization energy. After the removal of one electron, there is a nuclear force. Nuclear force gets more now as compared to the electronic force. Now, if you compare the nuclear force with compared to electronic force, then nuclear force magnitude of nuclear force gets increased, not get is becomes more. So due to which there is a contraction in size takes place. There is a contraction in size takes place. Now what happens? This is of magnesium ion. One electron has lost, but yet magnesium has to lose second electron in order to achieve the electronic configuration like of neon. So my dear student, now you see that the size of ion gets reduced. Now size of ion, magnesium ion gets reduced, and again you want to remove another electron. So it means here now the force acting between the nucleus and that electron, the force acting between the nucleus and the outermost electron or valence electron present in magnesium ion. The electron present in the outermost shell of a magnesium ion, due to contraction in size, due to decrease in size, now the force acting between them becomes large, because yesterday we have discussed force is inversely proportional to the square of the distance. Now distance gets less, force becomes more. So now force is stronger, and yet you want to remove the another electron, then obviously you have to apply more energy, IE2. So the magnitude of IE2 will be greater than the magnitude of IE1. So whenever if you want to lose the second electron from an atom, it means you have to supply more energy as compared to the first ionization energy. So what I am trying to make you understand here you see, if you talk about the third, aluminum, there is a 3 electron, silicon 4 electron, yet amount of energy will increase. So it means ionization enthalpy value, what will happen? Increases. The amount of magnitude of ionization enthalpy value increases while moving from left to right across the period. Once again, please, what is ionization energy? The amount of energy required to remove an electron from an isolated gaseous atom. So what is a trend across the period? While moving from left to right, across the period, the magnitude of ionization enthalpy increases due to decrease in the size of an atom. Because yesterday we have already studied that while moving from left to right, the size of atom decreases. Not only decreases, number of electrons also increases. So while moving from left to right, the magnitude of ionization energy increases. Now next characteristics we are going to discuss is nature of oxide. Nature of oxide means basic behavior or acidic behavior. Now as you know that sodium oxide is a basic in nature, magnesium oxide is basic in nature but less than sodium. Magnesium oxide is a basic in nature but their basicity is less than sodium. Now aluminum oxide is amphoric in nature Aluminum oxide is amphoteric in nature. It means it has acidic as well as basic properties. Now, silicon dioxide is a slightly acidic in nature. Slightly acidic in nature. Phosphorus is acidic in nature. Sulfur dioxide is strongly acidic in nature. Chlorine oxide is also acidic in nature. So what is happening? Once again you see it. Sodium oxide highly basic, magnesium oxide high basic, aluminum oxide amphoteric, silicon slightly acidic, phosphorus oxide is slightly acidic in nature, sulfur dioxide is strongly acidic, chlorine oxide is also strongly acidic in nature. So what is happening? Nature of oxide, basic character decreases and acidic character increases. Basic character increases, basic character decreases and acidic character increases. So while moving from left to right, across the period, from left to right across the period, basic character decreases and acidic character increases. So while moving from left to right across the period, the basic character decreases and acidic character increases. Now next characteristics is a metallic character. Metallic character and non-metallic character. So once just recall it from the metal chapter, metal and non-metal. When we say metal, obviously it comes in our mind that tendency to lose electron. Once it comes in our mind about the metal, it is one of the feature of metal, no? That if it is a metal, it means it has a tendency to lose electron and form electropositive ion. When we talk about the non-metal, just opposite of it, it has a tendency to gain electron and forms electronegative ion. So my dear student, just you say that sodium, magnesium, aluminum. Sodium is a highly electropositive. Highly electropositive means it readily loses electron. Sodium readily loses electron. Now again if you go back, then factor is size. Why sodium is able to lose electron very fast as compared to magnesium, as compared to aluminum? Because of sodium is a bigger in size as compared to magnesium. So sodium loses electron fast. And not only that, sodium gets stability by losing only one electron. But at the same time, with magnesium, first of all, magnesium is smaller in size as compared to sodium, and magnesium has to lose 2 electrons in order to achieve the nearest noble gas configuration. So it means sodium is highly electropositive, highly metallic. Magnesium less, aluminum yet less. silicon will be very less. Phosphorus has almost no tendency to lose, rather it has a tendency to gain electron. So now phosphorus onwards has a tendency to gain electron. Now sulfur has more tendency, sulfur has a more tendency to gain electron as compared to phosphorus, because as you know that sulfur is a smaller in size as compared to phosphorus. In a non-metal reactivity, what I said, non-metal has a tendency to gain electron, and this gaining takes place easily if the size of atom is small and number of electron required less. So is compared to sulfur, if you are going to compare sulfur and phosphorus, sulfur is smaller in size as compared to phosphorus, and sulfur needs 2 electrons. At the same time phosphorus needs 3 electrons. So sulfur gets more electronegative as compared to phosphorus. Now if you talk about the chlorine is the smallest in size along this period. Yesterday I have mentioned it. Along the period, if you talk about the first group, the sodium is in any period, the first period atom is larger in size, and the 17th period element is the smallest in size. So now chlorine is the smallest in size in this period, and it requires 1 electron, so it is a strongly electronegative in nature. So it means it is a strongly non-metallic character. It has a strongly non-metallic character. So what happens while moving from left to right? While moving from left to right, metallic character decreases and non-metallic character increases. While moving from left to right, 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 left to right across the period, metallic character decreases, metallic character decreases, and non-metallic character increases. So while moving from left to right, across the period, metallic character decreases, non-metallic character increases. Thank you. Have a nice day.